All right, so I didn't record what I just talked about. All I talked about was setting up which direction I want to do. 9 a.m. does better than 8 a.m. So I would choose to do 9 minus 8, and that's greater than 0 as my alternative. But this is the same thing as doing mu of 8 minus mu of 9 would be less than 0. So we're going to go to calculator and do. Let's go ahead and write down our stuff. So if I chose to do 9 minus 8, the way my brain works, I need to write everything for 9 first so I don't mess myself up, because I would. So I'm going to choose to go ahead and write everything for 9 a.m. first. So what is our X bar for 9 a.m.? And then, so I'm going to write all my stuff for 9 a.m. first. So 44.9. Am I going to write S or sigma? So S of 9, which is, and then my N for that one is 31. Then I've got 40.2, 9.57, and 34. Just talking about these right here, if I said, let's look at these, what do I know about my different classes? What could you say, just based off of this? Say, descriptively tell me about the 2 classes just based off of this one number. What would you say? So that means they are, who's more consistent? So my 9 a.m. is definitely more consistent. This bigger spread means that the scores vary a lot more. They're less consistent. All right, so equation, just like before, I'm making you do the generic equation. So I'm going to write X bar what? The way I set my problem up. Minus X bar 8. I do those parentheses and they don't need to. Minus what? 0 over square root of what goes on top? Over plus over. So even though we don't have any t's that we have to plug in like we did yesterday, and that was the whole reason for avoiding plugging numbers in, so here I'd be fine doing it. But because these are all very well written out and labeled, and this is all very well written out and labeled, I'm not making you do that filled in equation for anything for this chapter. Now, like I said yesterday, if you mess up one of them or leave something out, I'm now counting off for both of them. So some people choose to write it out anyway. Or if you're doing it by hand, I would write it out anyway. So stat tests, 1 or 2. We're dealing with 1 or 2 sample. 2, is it going to be sample or proportion? Sample, because proportion or sample means Z or mean. Z or T? So it's what number? Test or interval? Test, so it's what number? What number? 4. So we've got 2 options, data or stats. Do I have the data? No, I do not have the list, so I go to stats instead. And so I just input my data. So in X1, X bar 1, I put what? 44.9, then 4.86, 31, and then 40.2, 9.57, 34. So you should be plugging those in like this. 31.2. Am I doing not equal to, less than, or greater than? I always get people who get confused with this, and you shouldn't be. You have set up the order for which one comes first and which one comes second. So you don't have to sit there and think about this. You literally write, did I write not equal to, did I write less than, or did I write greater than? Don't go back and think through that like a thought process. So we wrote greater than as our alternative. So we're clicking on that third one, which is greater than. We're not pulling because we're not doing that with means. Calculate, and it now gives me my T, my P, my degrees of freedom, and it shows me everything that I entered again, the X bar, S, and N for both my samples. So at this point here, I write that giant equation equals what? Then I do what? So I draw it, that's a positive number, so it's over here. I shade which way? Greater than, so I'm shading to the right, and I get a p-value of Did this one give us an alpha? What was it? This number is, which means we reject our null hypothesis that mu9 minus mu8 equals 0. Since the p-value is less than alpha, we do have convincing evidence that what in context, if I asked you to say what do we have significant evidence that? The mean of the 9 a.m. class did do better than the mean of the 8 a.m. class. You're not really going to have to write out all that because we would just do, since I haven't written one of these yet, let's just do it. So we reject the null hypothesis that mu9 minus mu8 equals 0. So this is no longer the case because we reject that. Why do we reject it? Since the p-value is less than alpha. So we do have enough convincing evidence So based off what I told you a second ago, what do you need to write right here? And then what? And so that's all you have to write. Me just making sense of it would say that means the mean score for the 9 a.m. class is significantly higher than the mean score for the 8 a.m. class.
So you wouldn't be able to generalize that if it says in the end of the problem that it says students in 9 a.m. classes do better than the other.
Yeah, and some of these I write up really quick. Some of them I take like pieces of stuff and then try to condense it so that we're not just dealing with all the wording for the whole problem. You're right, you could not generalize it because we didn't randomly select, but the way the problem asked with what I included.
So it would have to be like that.
One of our homeworks, the one about the preschool, not preschool, was what, do you remember the preschool, not preschool, which condition was not met? It was random that was not met. Basically, that was in context one of those things where they want to follow these kids and see if there's reason to get into all of the money and funding and programming to try to make this better. They couldn't apply the results to the population yet, but that would be a ridiculous study to try to like randomly select these poor kids You're like, you're poor. Can I put you in preschool? You're not poor. I'm not going to give you preschool. And then moral and ethics and stuff would come along. So there's still a lot of benefits in it, but you should kind of make sense of why we can't technically generalize that one. But we should still be able to see a good picture. That one had a whole bunch of kids in it, right? Like hundreds, both of them, I think. So like they'd still get a really good picture of whether it would be worth getting into this or not, even though technically that condition was not met.